In this segment, what I'm going to do is I'm going to face head-on a problem that bugs people. So be warned. You're going to be uncomfortable, perhaps, for a little bit. The problem is simple. I have a tiny little box. It has 5 tickets in it, one of which is red and the other 4 are green. What I'd like you to imagine is that the other side of the ticket is just white. You cannot tell from the other side what color the ticket is. And I'm going to draw at random from this box, which means I'm going to shuffle and pick. And the question that I'm going to ask you is about the second draw. What is the chance that the second ticket drawn is the red one? Now, before you can answer that, I do have to tell you exactly how I'm drawing. Yes, I'm shuffling and I'm drawing, and then what am I doing to that first ticket before I draw the second one? Am I throwing it back or not? Well, we'll do it both ways. With replacement, that is, I throw the ticket back and then draw the second one, well then what is the chance that the second ticket drawn is red? That's easy, because the second draw is from exactly the same box as the first draw was, and the answer is simply 1 in 5, and I'm done. It's a little more interesting when you draw without replacement. So the picture is this. I shuffle, draw once, shuffle the rest, draw again, and it's that second ticket that I'm going to look at. And we're asking, what is the chance that that second ticket is the red one? Is there a chance that the second ticket is a red one? Well, it could be, right? It could be red. So yeah, there is a chance. And it's our job to find what it is. And in order to answer this question, it is a great idea to understand the question. And for this, I find a visual helps. So imagine that I have shuffled my 5 tickets and I have dealt them one, but there's the first one that I dealt. Here's the second one. This is the one I'm wondering about, and then there's all the rest. It's this one, and we want to know what is the chance that that is the red ticket. Well, it's clear from the picture that there is a chance, and we need to be able to identify what it is. So how are we going to do that? Well, somewhere is the red ticket. We don't know where it is, because we've put the tickets face down. Where could that red ticket possibly be? Could it be here? Sure. Could it be here? Yes. Here? Yep. Here? Yes. What about here? Yes. That red ticket could be in any one of these 5 spots. Now, is any of those spots more likely than any other? No, if you've shuffled all the tickets, then all of those spots are equally likely, and that is an important observation, because that red ticket has the same chance of being in any one of 5, count them 5, positions. So what is the chance that it's in this position? Well, that's 1 out of 5 equally likely positions, and so the chance that it's in position 2 is 1 in 5. Please pay attention to that, because people desperately want a 4 in the answer because you're drawing without replacement. But no, the red ticket could be anywhere. All positions equally likely. The chance that it is here is 1 in 5. And you know, I can't see you. I'm in a different continent from you, but I can hear your screams. But you said you're drawing the first ticket. The first ticket isn't there. Okay. I'll draw the first ticket. Here we go. All right, so they were all shuffled. And this guy, I took it out and I moved it all the way over here. Same question. What is the chance that this one is the red ticket? Lo and behold, same answer. Where could that red ticket possibly be? It could be here, or here, or here, or here, or indeed all the way over here. It could be in any one of 5 available spots. Each of those spots is equally likely. It doesn't matter where you have put this ticket. What matters is that this ticket exists. And that red ticket could have gone in that spot. Same argument. It doesn't matter where the tickets are. That red ticket has 5 equally likely positions it could be in. The chance that it's in this position is 1 in 5. And while we're about it, what's the chance that it's in this position right here? Also 1 in 5. It's 1 out of 5 equally likely positions. People get terribly het up about this card. Because yes, I agree, if this was the red card, then the others couldn't be. So also if this was the red card, then the others couldn't be. What you're trying to figure out is where is that red card in the deck. And so it is a revelation to many people that if you draw at random from this box, or indeed any other box, but for now we are focusing on this box, and you look at the second draw, the chance that any particular ticket appears is the same whether you are drawing with replacement or without replacement. And it is important to note the kind of chance that has been asked for. I haven't told you anything about any other card, so what you are being asked for is an unconditional chance. You have no idea of where the other cards have landed up. And that is the key reason why the answers are the same. And I know this leaves people in some state of disquiet, and the calculation is reassuring. I'll do the calculation just because people insist on doing it. So we want the chance. Now I'm doing the calculation in the case we are drawing without replacement. So it's a correct observation that for the second draw to be red, the first one had to be green. There's no other way. So the event second draw red is the same as the event first draw green and second draw red. Do we know how to find the chance of this? You bet, multiplication rule. The chance that the first draw is green is 4 in 5 times the conditional chance that the second one is red, given that the first one was green. That's 1 in 4. So you cancel, and lo and behold, you have 1/5. And people take a deep breath and say, yeah, now there's a proof. Yeah, okay. But it's important to understand the symmetry. It's really important to understand the symmetry, because I am going to move away from this tiny little deck of cards and 2 draws to a standard deck which has 52 cards, 26 of which are red, and I'm going to deal at random with replacement from this deck. Excuse me, at random without replacement, crucially, from this deck. And the question I'm going to ask you is, what is the chance that the 17th card that I deal is red? Now, you really, really, really don't want to be thinking about the colors of the first 16 cards. What do you need to think about? Just that one position. Pick your favorite red card. Pick the Ace of Hearts. Where could the Ace of Hearts possibly be in the well-shuffled deck? Well, it could be in any one of 52 positions. So what is the chance that it's in this particular position? Well, it can be in any one of 52 equally likely positions, so the chance that it's in this position is 1 in 52. That's true for all of the red cards. Any of the red cards is equally likely to be in this position as any other, and the answer is the chance that this position has a red card in it is, yep, 26 in 52. The number 17 appears nowhere in the answer. The particular position you're talking about is not important, and one way to understand that is if I had given you the cards dealt in a circle. By looking at that circle, you could not tell which is the first card, which is the third card. So really, all of those cards probabilistically have the same status. The answers will change if I give you a little bit more information. So next, what is the chance that the 17th card is red? And now I'm going to tell you that the 32nd card was black. I have dealt the whole deck, and I am willing to now feed you a little bit of information. Card number 32 was black. So now what's the chance that card number 17 is red? Well, how many cards could possibly be in position number 17? 51, because I have used up a black card in this position. 51 could be here. How many are red? Well, of those, 26 are red because I have used up a black card. And so my answer is 26 and 51. I'm done. Had I changed the question, had I said what is the chance that the 17th card is red given that the 32nd card is red, then the answer would have been almost the same. I would still have only 51 cards that can occupy this position because I have used up one card in position 32 and I know that it's one of the red cards. So I have 15 cards that can go here, of which 25 are red because I have used up a red card in position 32. And so my answer is 25 in 51. Look, no hands. No multiplications, no counting. Well, no serious counting anyway. By symmetry. Symmetries in sampling without replacement are going to be very, very important. And it is a good idea to get used to them. I appreciate that they're a little bit unsettling in the beginning, but they are central to understanding random samples. And so to summarize what's happened here, let's make the main observations, which is when you're talking about probabilities of cards appearing in certain positions, the particular positions don't matter. What matters is how many cards you know about. Alright, when you know about card in position 32, that it's in position 32 hardly matters. What matters is you know about one card. And so that drops one card from your deck. So just to recap and to make sure that we can separate one kind of probability from another, I'm going to deal cards from a well-shuffled standard deck. That means I'm going to deal at random without replacement, and I'm going to find a bunch of chances. Alright, the 40th card is an ace. Let me remind you that there are 4 aces in the deck and there are 52 cards. So the chance that the 40th card is an ace is, thank you, 4 in 52. Each card is equally likely to appear in place number 40. 4 of those are aces, so 4 in 52. Great. What is the chance that the 50th card is an ace? Same thing. Each card is equally likely to appear in place 50. There are 4 aces out of 52 cards, and so the chance is 4 in 52. Let me take a moment now to address those people who are thinking, well, wait a minute, the 40th card was an ace. The 40th card was not an ace. I didn't say it was. I asked you to find the chance that it was. If I ask you to find the chance that you win the lottery, trust me, I'm not telling you you've won the lottery. So, the chance that the 50th card is an ace is the same as the chance that the 40th card is an ace is the same as the chance that the first card is an ace, which is 4 in 52. And now, if I ask you what is the chance that both of those cards are aces, number 40 and number 50, both aces, then what are you going to do? Well, 2 things both have to happen. You better use multiplication rule. So what is the chance that the 40th is an ace? 4 in 52. And you multiply by what? You multiply by the conditional chance that number 50 is an ace given number 40 was an ace. And so you have 4 over 52 times 3 over 51. And I want to focus on that 3 over 51. The multiplication rule says take the chance of the first thing, multiply not by the chance of the second thing, but by the conditional chance of the second thing given that the first one has happened. once card number 40 is known to be an ace. You have 51 cards left in your deck, of which 3 are aces, and that 3 in 51 is a conditional chance of ace on place 50 given ace in place 40. The 4 in 52 is the unconditional chance of ace in place 50 given nothing at all.